hydrostatic pressure on submerged rectangular surfaces. A body submerged in a liquid, such as a gate valve in a dam, in a dam or the wall of a tank, is subjected to fluid pressure acting normal to its surface. And distributed over its area. In problems where fluid forces are appreciable, we must determine the resultant force due to the distribution of pressure on the force and the position at which its resultant acts. For systems open to atmosphere, the atmosphere pressure P0 acts over all surfaces and does yield a zero resultant. In such cases, then we need to consider only the gauge pressure, which is the increment above the atmospheric pressure. Consider the spherical but common case of action of hydrostatic pressure on the surface of rectangular plate submerged in a liquid, shown in this picture. This figure shows that such a plate 1, 2, 3, 4, the green plate here, 1, 2, 3 and 4. With its top edge horizontal and with the plane of the plate making an arbitrary angle theta with the vertical plate as shown in this picture, theta with the vertical plane. The horizontal surface of the liquid is represented by the x y prime plane, this horizontal plane. The fluid pressure acting normal to the plate at point 2 is represented by the arrow 6-2 and equal rho g times the vertical distance from the liquid surface to point 2. this arrow. The float pressure acting normal to the plate at point 2. This same pressure acts at all points along the edge 2 to 3. And for the point 1 we have the same description. At point A on the lower edge, this point, the fluid pressure equals rho g times the depth of the point 1 and equals to this R. And this pressure is the same at all points along the edge 1 to 4. The variation of pressure P over the area of the plate is governed by the linear depth relation, and therefore it represents by the arrow on P resultant shown in this picture. So consider this picture for more description in the slide view. The resultant force produced by this pressure distribution is represented by R, which acts at the same point P called the center of pressure. This point, center of pressure. The condition which prevail at the vertical section 1, 2, 6, 5, 1, 2, 6, 5 shown here, 1, 2, 6, 5 are identical those at the section 4, 3, 7, 8 at every other vertical section normal to the plate these points. Thus we may analyze the problem from the two-dimensional view of a vertical section as shown in the picture here. For this section, the pressure distribution is trapezoidal. If P is the horizontal width of the plate measured normal to the plane of the figure shown, an element of plate area over which the pressure P equals to this element P pressure equals to rho g h. H is this distance, h acts on dA and an increment of the resultant force is dr equals to pdA equals to p b dy, but p dy is merely the shaded increment of trapezoidal area dA prime, this area, so that dA p dA prime. We may therefore express the resultant force acting on the entire plate by the trapezoidal area 1265 as shown in the picture by the integration. So consider these pictures again. From this picture, r equals to b integration of dA prime dA prime. Be careful not to confuse the physical area A of the plate with the geometrical area A prime defined by the trapezoidal distribution of the pressure. A prime is this area is A prime. A prime trapezoidal area of pressure distribution. And difference with the plate area. The resultant force R may be therefore be written in terms of average pressure. So R can be represented by P average, which is equals to 1 second of P1 plus P2 as shown in the picture here, P1 and P2. The average pressure is also pressure which exists at the average depth measured the centroid O of the plate. An alternate expression for R is therefore P average multiplied to A rho GH bar multiplied to A. Where H bar Y bar cosinus theta. Y bar is the distance to the centroid of the plate from the fluid free surface. We obtain the line of action of the resultant force R from the principle of moment. Using x-axis as the moment yield, we can obtain the line of action, the point of action, y bar, point of resultant line of action of the resultant bar. Consider this picture. Y bar the A prime. A prime is trapezoidal area of distributed force. Which is simply the expression for centroidal coordinate of trapezoidal area A prime. In the two-dimensional view, therefore, the resultant R passes through the centroid C of the trapezoidal area defined by the pressure distribution in the vertical section. Clearly, Y bar also locates the centroid of the truncated prism as shown in the picture. For a trapezoidal distribution of pressure, we may simplify the calculation by dividing trapezoidal in a rectangular and triangle shapes. The next section is hydrostatic pressure on cylindrical surface.